This is Mr. Alexander, and I want to talk to you about what we're doing on the 5th day of our logarithms and exponential function unit, which is applications of exponential models. So I'm just going to solve some of these problems here, see how much we can get done in the next 15 minutes. In an experiment, researchers found that a specific culture of bacteria increases in number according to the formula n equals 150 times 2 to the t power, where n is the number of bacteria present and t is the number of hours since the experiment began. Use this formula to calculate the number of bacteria present at the start of the experiment. So at the start, that's when t equals 0. So that would be n equals 150 times 2 to the 0th power. Anything to the 0th power equals 1, so that's just 150 times 1, which is 150 bacteria. The number of bacteria present after 3 hours, that's going to be n equals 150 times 2 to the 3rd power. And that looks like a good spot to use the calculator. So 150 times 2 to the 3rd power, that's going to be 1,200 bacteria. And then part C here says the number of hours it would take for the number of bacteria to reach 19,200. So I'm just going to plug in 19,200 for the value of n there. 19,200 equals 150 times 2 to the t power. I need to get that t by itself, so I'm looking for the number of hours. So I'm going to divide both sides by 150. So 19,200 divided by 150 is 128, which equals 2 to the t power. At this spot, I'd encourage you to go ahead and take the log, just the common log of both sides. Or if you prefer, you can take the log base 2 of both sides. I'm just going to go ahead and take the log of 128 and set it equal to the log of 2 to the t power. When you do that, you can bring that t out here in front of log base 2. So I've got log 128 equals t times log of 2. And to get that t, we're just going to divide both sides by log of 2. So then time equals log 128 divided by log 2. And we should go ahead and type that into the calculator. Log 128 divided by log 2. That's going to be 7. Now don't forget your units on that. That's going to be 7 hours. Alright, so that was the first problem on this thing. I want to go ahead and look at number 4 next. Number 4 says the graph below shows the curve y equals k times 2 to the x power plus c, where k and c are constants. And we're supposed to find the values of c and k. I think a good place to start is right here. We can see that this exponential has a horizontal asymptote at y equals -10, which means that this function from the parent function, normally the parent function has that asymptote right there at y equals 0. So I know this thing has been shifted down 10 units. So that value of c right there, that must be -10, because that's the only way we're going to shift this thing up or down. So based on the horizontal asymptote, c equals -10. I can use that information to figure out what k is. So I'm going to go ahead and plug c into my equation here. I've got y equals k times 2 to the x power minus 10. To solve for k, we need to plug in for the other two variables, x and y. And I'm seeing a couple of good points here we could use to do that. 1, 0 looks like a good option, and so does 0, okay, that's points halfway between 0 and -10, so that's -5. I'm going to go ahead and use 0, -5, but you could just as well use 1, 0. So my y is -5, which equals k times 2 to the 0th power minus 10. Remember that anything to the 0th power equals 1. 1 times k is just k. So this is -5 equals k minus 10. To get k by itself, we're going to add 10 to both sides to get 5 equals k. Therefore, the equation of this particular graph is y equals 5 times 2 to the x power minus 10. That's the full exponential equation based on what I've just found here. The next one I'd like to talk about is number 6. On number 6, we've got another word problem here. The amount of electrical charge C stored in a mobile phone battery is modeled by the function C of t equals 2.5 minus 2 to the negative t power, where t in hours is the time for which the battery is being charged. Write down the amount of electrical charge in the battery at t equals 0. So I'm looking for C of 0, which is just function notation, meaning what's the charge when the time is 0? It's 2.5 minus 2 to the negative 0, which is just 0, of course. Anything to the 0th power is 1. So what I've got here is 2.5 minus 1, which equals 1.5. And it's not really clear what the units on the electrical charge is, so I'm just going to leave the units off. We'll just call it 1.5. The line L is the horizontal asymptote to the graph. Write down the equation of L. Well, remember, a horizontal asymptote is always in the form of y equals something. And the question is, y equals what? So they've drawn it here for us. You can always just steal it from the equation. It's always the constant in the equation. It's just going to be y equals 2.5. Just like in the one we just did, it was y equals negative 10. It comes directly from the equation. Last part, part C. To download a game to a mobile phone, an electrical charge of 2.4 units is needed. Find the time taken to reach this charge. Give your answer to the nearest minute. So I'm going to start with that 2.4 they gave me. I'm going to set it equal to the equation 2.5 minus 2 to the negative t power. And I need to solve for t. So we're going to take a log at some point. But the first thing we ought to do is subtract 2.5 from both sides. That will give me negative 0.1 equals negative 2 to the negative t. I'm going to go ahead and divide both sides by negative 1 to get rid of these negatives. Make it 0.1 equals 2 to the negative t. At this point, I'm going to take the log of both sides to get rid of this exponent, or not get rid of it, but to bring it down into, get it out of the exponent. Log 0.1 equals negative t log of 2. So I just brought the exponent down when I took the log. To get negative t by itself, we're going to have to divide both sides by log of 2. So negative t equals log 0.1 divided by log 2. And I'm not interested in negative t, I'm interested in t, which is negative log 0.1 divided by log 2. That sure looks like something I probably ought to type into the calculator. So let's go ahead and do that. Negative log 0.1 divided by log 2. That's going to give me 3.322. 3.322. And what was the units on that? That was, oh, I circled it, hours. But read what the question's asking you. Give your answer correct to the nearest minute. So we know it's going to be 3 hours and some number of minutes. The question is, how do I turn this 0.322 into minutes? Well, if you just take that decimal and multiply it by 60, the number of minutes in an hour, you'll have the number of minutes. So I'm going to take that 0.322 times 60. It's 19.32, so if I round that to the nearest minute, that's 3 hours and 19 minutes is the correct answer. And if you'd prefer to leave the hours out of it, you would just do 3 times 60 plus 19. Another acceptable answer would be 199 minutes total. I've got time to do 1 or 2 more of these. So the next one I want to talk about is number 10. So consider the function f of x equals 1.25 minus a to the negative x, where a is a positive constant and x is greater than or equal to 0. The diagram shows a sketch of the graph of f. The graph intersects the y-axis at point A, right here, and the line L is the horizontal asymptote. Find the y-coordinate of A. Well, notice that A is at 0 for x, and we don't know the y. So if I plug a 0 into this equation, I should probably have the y-coordinate. So f of 0 equals 1.25 minus a to the negative x, which our x is just 0. So a to the 0th equals 1. So 1.25 minus 1, well, that just equals 0.25. So this y right here is 0.25. Okay? The point 21 lies on the graph y equals f of x. Calculate the value of a. All right, on this one, we are given, zoom in a little bit, we're given the equation, we're given an x and the y, we just need to plug in the information we have. So the y that we're given is 1, so for f of x I'm going to plug in 1, and I'm going to just go with the equation here, 1.25 minus a to the negative 2. Alright, so I should be able to solve for a, given this information. Subtract 1.25 from both sides first to get negative 0.25, which equals negative a to the negative 2. Get rid of those negatives, make it 0.25 equals a to the negative 2. And then from here, there's a couple different ways to think about this. But my preferred method, I think, is just to raise both sides to the negative 1/2 power, because those negatives will cancel out, and the 2 and the 1/2 will make this a 1. So it's a negative 1/2 power right there. And when I do that, that's calculator work. So 0.25 raised to the negative 1/2 power is 2. Therefore, a must equal 2. Now we can check that by plugging that directly into the equation that they gave us and making sure we got the same points that we're supposed to get. So 1.25 minus 2 to the negative x power, like that. We should go to the table. We've got 0.25, just like we thought we would, and we've got 2, 1, just like we thought we would. And then if you graph it, you could probably see what's going on here too. That graph, well, if we change the window, but the shape looks approximately how it's supposed to look. All right, there's one more part to this. Write down the equation of L. The L is, again, just this horizontal asymptote, y equals something. And again, that comes directly from the equation, 1.25. Now, just so that you believe me, I'm going to go to the table in my calculator here so you can see that this thing approaches 1.25, but it's not going to get there. You can keep on going. It's going to get real close. Now, it looks like it's at 1.25 here, but your calculator's just rounding. If you actually keep going down, you'll see this thing's getting closer and closer to 1.25, but it's not actually getting there. So the equation of L is y equals 1.25. Unfortunately, I am out of time. I would have loved to do more of this. I enjoy spending this time with you. This has been lovely. Thank you for watching. We'll see you on the next video.